with standard 1.3. It's positive and negative rational numbers. If you remember, we learned this standard at the very beginning of the year, so most of you probably need some review on it. Now if only my, there it goes. Okay, so the first thing is we need to be able to construct a number line from negative 10 to positive 10. Hopefully you remember how to do this. I'm going to go ahead and draw it here. We know that 0 is right in the middle. And we know that the positive numbers count up, just like they always have. And then if you remember, 0 acts like a mirror. So everything that is over here on the positive side is going to be the same on the negative side. Oops. So if I have 0 here, that means negative 1 is going to reflect right here. Then I will have negative 2. Then it's just counting the same, except that I have a negative in front of every number. Negative 3, negative 4, negative 5, negative 6, 7, 8, 9, and negative 10. Now, it says down here that it wants me to find 8 and its opposite. So 8 is not so bad. Here's 8 right here. The opposite of 8, if you remember, is just a negative 8. So over here is its opposite. If I started and I said, oh, it's 10 degrees outside, and then I want, no, it's 2 degrees, because I want 10 degrees less than 2 degrees. So it's 2 degrees outside right now, and I want to know what it is. If it's 10 degrees less, it falls another 10 degrees. I'm just going to count down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm at negative 8 degrees. So negative 8 degrees would be 10 degrees less than 2 degrees. If I were to construct a number line from negative 1 to positive 1, but I want it in increments of 1/10, it's going to be a lot like the one you just constructed, except that in the middle is 0. All the way over here is going to be a positive 1. All the way over here would be a negative 1. And then if I'm counting in increments of 1/10, I'm going to actually change it to a decimal because it's going to be a little bit easier to fit in. That's 0.1, 0.2, 0.3, 4/10, 5/10, 6/10, 7/10, 8/10, and 9/10. And when we get to 10/10, that's the same thing as 1. Over here, it's going to be everything opposite, just like a mirror. I'm going to let you finish this one out because I'm pretty sure you can count okay. So then I'm supposed to find 4/10 and its opposite. Well, here's 4/10. The opposite of 4/10 is a negative 4/10. The next thing it asks me is which is larger, negative 3/10 or negative 4/10. Well, I'm going to start over here at, here's negative 3/10 and here's negative 4/10. And I hope that you remember, the further we go this way, the larger our numbers get. If we're all the way over here, it's at 1,000,000. But if we're down here at 0, it's smaller. So the further this way, the larger our numbers get. So that means that 3/10 is actually larger than 4/10 because it's closer that direction. What is the definition of absolute value? The definition of absolute value is the distance from 0. If you think about distance, distance is never negative. You can never have a negative distance because even if you drive your car backwards, you're still going somewhere. So the distance from 0, so 7 is just 7. Absolute value of 7 is just 7. The absolute value of a negative 5 is just 5. Negative 2.3 is just 2 3/10. 4.3 is just 4 3/10. 3 halves, even though it's a fraction, that's still how far it is from 0. 3 halves. And then a negative 2/9 is just 2/9 from 0. Don't make it harder than it is, but remember absolute value is how far something is from 0. Robert recorded the temperature outside his house in the table shown. At 4 o'clock, it was 15 degrees. At 6 o'clock, it was negative 7 degrees. He claims that the difference between the temperatures is 8 degrees. Why is Robert's claim incorrect? We already know that it's incorrect, but we want to know why. So one way you could think about it is if it's 15 degrees, it's going to take me 15 degrees just to get to 0. And then I have to go -7 more. So if I think about the absolute value of -7, that's 7 more units away. So I'm going to actually have to add the 15 plus the 7 more that it takes him to get all the way down to -7. So he's actually 22 degrees away instead of just 8. If he only felt 8 degrees, it would be positive 7 degrees outside instead of a -7 degrees outside. Jose is transferring this drawing of a triangular roof to a coordinate plane. He plots the points at -5, 2, so that's this point here. We went in the house, -5, and then up 2. And then 0.16, so on the x we're going over 1, and then up 6 on the y. And it says the length of the base of the roof is 12 units. I'm going to count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means if I want my roof to be 12 units, this is the other point. And it says it wants me to plot point C and then connect the 3 to make the roof outline. So here's point C, and then I'm just going to connect it. Yikes, clearly I can't connect very well on this thing. So then if it asks me where point C is, well, I start at the origin always when I count. And I'm counting on the x first. 1, 2, 3, 4, 5, 6, 7. So my coordinate is going to be 7. And then I'm going up 1, 2, 7. This one's really tough. It wants me to plot these points down here. So it's telling me that A is over here, and then B. Here's how I think about this. I think about A is at 2. So I'm going to say A is equal to 2. And then B is up 1, 2, 3. So I'm going to say B is equal to 3. Then I'm going to plot C. C is in the house 1, 2, 3, 4, but it's in the negative direction, so it's going to be -4. And then D is also up 2 units. So now if it wants -AB, well, -A is going to be a -2. 1, 2, and then B is up 3. 1, 2, 3. So this is the first point right here, -AB. A is at 2, so 1, 2, and then a -B is going to be going down 3. 1, 2, 3. This is the next point right here. And then finally a -C, -D. Well, C is here. We went this way first, so instead of a -4, I'm going to have to go opposite of a -4, which is a +4. And then D was up 2, but now I'm going to go down 2. So this is the final point right here. I'm going to go ahead and clear that one out. If you need to watch that again, you can definitely watch that one again. Last thing, what is the opposite of an opposite? So if I think about the number 2, the opposite of 2 is a -2. What would the opposite of the opposite be? So a -2, that would end up bringing us back to the original number. So the opposite of the opposite is the number we started with. And that is the end of all that you need to know, hopefully, for Standard 6.1.